I'm audible on YouTube. Yeah. Can you guys hear me?
Yes, sir.
On Google Meet? Okay. I hope you can see my screen. So let me try. Okay. So for some problem, you may need assistance. This what you call chapter have got varieties of problem. Okay. This one and last chapter also. Okay. That formalism chapter also. Okay. Varieties of problem. You need some practice actually. Even though you saw less than 50%, that's okay for me. Okay. In any topic, okay, if you solve more than 50% of the problem yourself, that's it. Okay. For the when you even if you take some time and solve more than 50%, that's okay. Okay. But here this chapter requires some more. Even two more classes are required. That's what I'm thinking. uh, Planar rotator, I think I talked about that one. Okay. If you write what you call, if suppose there is a particle on a ring problem. Okay. There are some questions related to that, and I don't know whether you've seen or not. Okay. If suppose this is xy plane. Okay. If particle of mass are moving on xy plane. Okay. It has only purely kinetic, rotational energy. Since it's what you call angular momentum is along z axis. Okay. We write Lz square by 2 into I. Hmm? If this is mass, if this is A, I is simply speak up 2 into mass into A square. Am I right? That's a moment of inertia of that. If you consider that one as a rigid body, okay. And this one to be taken as a Hamiltonian, okay. That's equal to Lz square by 2I, and we need to work out some problem related to this one, okay. Particle on a ring problem, okay. I'll work it out, okay. Right now, I'll pick some problem here, some special problem, okay. Speak up. That we didn't discuss, okay, in our theory. We didn't discuss this kind of problem in our theory.
So that Lz square by 2I.
Hmm.
That formula, how we get from.
Uh, just like what I remember is I don't know how to or to get into that one. Okay, so p square by 2m. Okay, in case of linear motion, L square by 2I. Okay, so half m v square, half I omega square. That's how I remember. Okay, I think somewhere in Halideresnik, he compared so nicely very long time ago. I do remember in this manner actually by comparing, or maybe H. Verma.
Is that first few vector?
Comparing, okay, so that you can remember, okay, pick up. Those will play the similar roles actually, okay. Speak up.
So we can convert that this magnetic line as that.
Your voice is not clear. Speak up again.
The position change that to LZ. That means linear momentum to angular momentum. Then
Yeah, that also you can do, okay. Speak up. You can write p square by 2m, and then you can, I think, convert that one, okay. Pick up. Now this kind of problem, okay, in cylindrical coordinate, which of the following is Hermitian operator, okay. Hmm? One thing is you don't know cylindrical, at least spherical polar coordinate we know right now. Okay. Because we need some vector calculus idea to solve this one. Okay. Or whether we solve during revision. Gradient is required in different coordinate to solve this one. Okay. Gradient we have taken in spherical polar coordinate. Okay. Maybe I might have written in uh, yeah, Cartesian and spherical polar. Okay. We need gradient concept here. Okay. So to do this one. Now, the thing that I want to tell you here is, okay, speak up. Suppose in case of one dimension, whatever px you have, what is this one? Minus I h bar dou by dou x. Okay, py, that's equal to minus I h bar dou by dou y. So pz, that's equal to minus I h bar dou by dou z. Okay, I can solve this one, but I want to give you what is the essence of the question. Okay, at least later during revision, when you are good with gradient and all, you can do it again. Okay, so these are all Hermitian, am I right? These are all Hermitian operators actually. Okay, even though you take this operator in 3 dimension, they are Hermitian. Okay, if I say suppose some inner product. Okay, pick up some psi star. Suppose px cap psi, okay, or I'll write like this, psi star of, okay, x comma y comma z, okay, pick up some px cap of psi of x comma y comma z, dx dy dz. Am I right? I mean, in case of 3 dimension, I mean, your inner product, that will be dx dy dz, isn't it? I'm talking about 3 dimension here, okay? Pick up, this is a triple integral actually, okay? Operating operator to, pick up, second member, okay, that's equal to operating its Hermitian conjugate to first member. That Hermitian conjugate is itself, actually it will come as it is here. And the main, what you call, reason for that is there is nothing here, am I right? Dx dy dz, there is no x or something. But in case of polar coordinate, d tau, that contain r square dr, am I right? Do you remember? So that play very important role actually, okay? Speak up. Here what you can do one integration by parts and you can take it here, isn't it? That's what we did. That's how we proved the Hermitian conjugation actually. You can do one integration by parts. But in polar coordinate, one more r square dr would come, right? When you take integration by parts, something else would happen actually. Speak up. So that's why this is equal to, so I can write like this, px cap dagger, that is itself, okay, psi of x comma y comma z, okay, whole star, am I right? Operating operator to second member is equal to operating its Hermitian conjugate to first member, psi of x comma y comma z dx dy dz. Is that okay? Speak up. Now what I'm saying is, I mean, if it is Hermitian operator, okay, speak up. Wait a second. If it is Hermitian operator, operating operator to second member is equivalent to operating the same operator to first member, isn't it? So this is true in case of Cartesian component of momentum. Any of the px, py, pz, whatever you take, this is true actually. You can just write dou by dou x, and you can do an integration by parts with respect to x. You can show this one. You leave y and z integral as it is. You leave that part of the integral as it is. Okay, you don't do that integral. You do only integration by parts in x. You can prove this one actually. Okay, but the same thing is not true if I define. So PR, I'll do in polar coordinate. Okay, pick up. Later maybe you can do in cylindrical coordinate. Let me do the, I mean, very similar problem in spherical polar coordinate. Okay, if I go to spherical polar, okay, pick up. I was talking about Cartesian here, okay, speak up. I was talking about Cartesian here. Wait a second. Okay, this is the problem. I was talking about Cartesian here. Speak up. Cartesian coordinate, okay? Your operator corresponds to component of momenta. Can I say like this? Okay, speak up. So if you go for spherical polar, okay, speak up. So if you define PR especially, okay, speak up. So I will come out with better idea. Maybe, I mean, in classical mechanics, if I think in this manner, I may get some idea. Okay, minus IH bar dou by dou R. Okay, speak up. Wrong. It won't work. Speak up. It is not Hermitian at all. Can you guess why? Speak up. When you do that integration by parts, something else would come to the left part actually. Speak up. I mean, if you just do this one, okay? Speak up. What is this one? Psi star of r theta phi, okay, into minus I h bar. Pick up. Dou by dou r of, okay, psi of r theta phi, okay? Speak up. R square dr, sine theta d theta d phi. Now it's not straightforward integration by parts actually. R square is there, including that one. I mean, with respect to R, suppose if you are doing only R part of the integral, okay, leave theta and phi later, okay, I'll leave theta and phi later. I'm doing 0 to infinity, speak up. So psi star of R theta phi, okay, so minus I h bar, I will take it outside, okay, So dou psi by dou r of r theta phi. Okay, speak up. R square dr. Am I right? Phi r square dr. Okay, speak up. You do this one. Sine theta d theta d phi. Are you getting my? So now again, it gives some issue. Is that okay? It gives some issue. I mean, how do you do integration by part? That itself is headache. Am I right? You have r square. Three functions are there actually. Okay, speak up. You may need to take r square into this side together, and then you need to do integration by parts. Again, you can't what you call make this derivative to come here because of this r square. I mean, that's how we did actually. Okay, speak up. I mean, integral, okay, psi star dou by dou x psi dx. Okay, we took one integration by part because at the boundary our wave function would vanish. First term of the integration by parts was 0. Okay, speak up. These were the argument that we have done actually. Speak up. But we can't do the same thing because of that factor r square. And one more thing, I don't know whether this will vanish at 0. Need not be, isn't it? 0 is not a boundary. Spherical polar coordinate origin is not a boundary. Boundary means end point, isn't it? It is bit what you call different. Okay, the whole problem is bit different. I had some other idea, now I can't recall. But what we can do is, this is not Hermitian. Okay, speak up. But what we can do is we can form a Hermitian operator like this actually. Okay, speak up. We can form a Hermitian operator. I mean, I did solve this one earlier. I mean, somewhere I found this idea from MIT Open Coursera. Okay, I mean, in our textbook it is not there. So it is like this: PR, that's equal to P vector dot R cap. Okay, R cap is unit vector, not article operator, plus R cap dot P. Okay, so divided by 2 actually. Actually, somehow you should able to prove that P cap dot R cap, it is not Hermitian. Okay, but this one is Hermitian actually. Pick up. This whole operator is Hermitian. This kind of problem is also there. Right now, I don't have that problem again. What was that problem? So this one, okay? Okay. So classically, you have some what you call Hamiltonian, that's equal to x into p. This was the problem, okay? Classical one, x and p are variable here. You need to construct quantum mechanical operator. What would you do? Because x into p is not Hermitian actually. X px, okay? This is a classical Hamiltonian. Is that okay? This is a classical Hamiltonian. Okay, speak up. So now, okay, classically this can be Hamiltonian. X is some real variable, px is some real variable. But if you write quantum mechanical operators, pick up x cap, px cap. Is that Hermitian? It's not Hermitian. Why? They do not commute. Am I right? Product of two Hermitian operator is Hermitian only if they commute. They do not commute. Okay, pick up. So that's why to form quantum mechanical Hermitian operator, what gimmick I do is I'll just write x px plus px x by 2. Now if you put cap, speak up, x cap, px cap plus px cap, x cap. Okay, don't take the derivative. You need to operate it on something. Okay, don't take the derivative and write 1 here. Okay, I mean, pick up. Be careful while using this operator 2 here. Okay. So can you just note down this one? Speak up. Is that okay? Very similar idea that I'm proposing here. Is that okay? Speak up. Very similar idea. So this p vector dot r cap, okay, that's not Hermitian, but this is Hermitian actually. Speak up.
You're taking some average or something.
No, I mean, how to prove? Let me think over it, okay? Because bit very new one. I mean, in our textbook, it is not there. I found it from MIT courseware, and I again. Speak up. Now this P vector is nothing but minus I h bar gradient. I'm doing in spherical polar. Okay, they are asking in cylindrical coordinate. Okay, speak up. This gradient in spherical polar coordinate, that is r cap by 1. I mean, why I write 1 is my practice. Okay, we call this as hr, h theta, h phi. I mean, like that. Okay, we shall discuss more in electrodynamics. Okay, dou by dou r. Okay, plus theta cap by r. Dou by dou theta. Okay, plus, I mean, this may be new for you. Dou by dou theta plus phi cap by r sine theta. Okay, dou by dou phi. This is gradient in spherical polar coordinate. Is that okay? If I take a dot product with r cap, I hope you can get what would you get here. Am I right? If you take a dot product with r cap here, okay, pick up. But you should be a bit careful while doing this whole stuff actually. Pick up. So now to find this operator, okay, speak up. To find this operator, again, as I always suggest, you better to operate it on some dummy function, then remove that function. Otherwise, some mistake will happen actually, because just like here, am I right? By operating in this dou by dou x on x, you may write 1 into minus I h bar. Am I right? That would be wrong. These two together, it is operating. What do you mean by that one? X cap operate first, after that px cap operate. Okay, speak up. So now what I'm saying here is, okay, what I'm going to do here is in the, I'll take in the next page. I'll take in the next page. Speak up. I'll operate this PR on some dummy function, that's r theta phi or something. Okay, pick up. What is this PR? So r cap, pick up. What I have written? P vector dot r cap. What is P vector? Minus I h bar. Okay, del dot r cap. Okay, operating on f plus what is this one? R cap dot p. Okay, speak up. So r cap dot minus I h bar del. Okay, speak up. Operating on f 1 by 2. I will keep it outside. Speak up. 1 by 2. I will keep it outside. Speak up. So now this is nothing but, okay. So I think I can take minus I h bar outside. Speak up. Minus I h bar outside by 2. Okay. Speak up. So now, so this is nothing but gradient dot, speak up, r cap f. Can I write like this? R cap f. Speak up. This one. So plus, okay, this is nothing but I minus I h bar have taken outside. R cap dot gradient of f actually. It's a kind of divergence. Okay, divergence, vector calculus divergence actually. Speak up. Minus I h bar by 2 that I have taken outside. Okay, I have done here in cylindrical coordinate, but I'm trying in a spherical polar coordinate. Speak up. So can you do this one now? Minus I h bar by 2. Okay, when you do this one, here also bit tricky step may come. Okay, what is this one? R cap into f. Am I right? I think that is simply divergence. How do you write the divergence in spherical polar coordinate? Again, this is also required. Divergence. Speak up. Divergence of a vector field in spherical polar coordinate. Any idea? 1 by r square sine theta. Am I right? Right? 1 by r square. AR. Am I right? That's right. Now, if you take this one as a vector, actually, I mean, it requires vector calculus. Okay, idea. Okay, so this is only r component actually. I mean, if you take this one as a vector field, okay, A is equal to r cap into f. Okay, so that means plus theta cap into 0 plus phi cap into 0 actually. Okay, that's how you have to see. Is that right? Sure. Okay. If this is right, then what I can do is, okay, PR into F, that's equal to minus IH bar by 2 minus IH bar by 2. Okay. Speak up. So this whole thing, uh, 1 by R square, okay, dou by dou R of R square into F. This whole factor. Are you sure R square or R? Yeah, check that out if you are holding Griffiths, okay? Speak up. So plus this is bit simple, I hope. Am I right? Speak up. This part is, I don't think that's much difficult. Am I right? You can write R cap dot. What is this one? R cap by 1 dou F by dou R. Okay, that's right. Is this right? Okay. So plus, I mean, theta cap by R dou F by dou theta plus phi cap by R sin theta. Okay, dou by dou phi of F. Okay, speak up. So now if I do this one, speak up, minus IH bar by 2. Okay, so these are orthogonal coordinate. R cap dot theta cap, R cap dot phi cap, that is 0 actually. Okay, they are orthogonal coordinate. So that's why only first term will remain. The whole thing is 1 by R square dou by dou R square F. Okay, speak up. So plus dou F by dou R actually. Speak up. Now you better to do this differentiation. Pick up. Minus IH bar by 2. Okay. Pick up. What is this differentiation? 1 by R square. Okay. R square as it is dou F by dou R plus F as it is. Pick up. 2R. Okay. Pick up. F as it is 2R plus dou F by dou R actually. Okay. Pick up. I hope when you multiply individually minus IH bar by 2. So R square got cancelled. Dou F by dou R. Okay. Plus 2R into F, am I right? Plus dou F by dou R. Can I write 2 times? I think this is right.
So 1 by R square will get multiplied to that also.
Okay. Here it will be multiplied to this one, am I right? By R square. Then I think this 2 got cancelled. Okay, minus IH bar. Okay, can I write like this? Dou by dou R plus 1 by R. Operating on F. Check this out. Am I right? Now somebody search in Google radial momentum operator in spherical polar coordinate and match up whether it is right or not. Okay, radial momentum operator. Maybe in the outside the textbook he might have given this problem either in this one TTL or somewhere. Okay, radial momentum operator in spherical coordinate. Yeah, that is right. That is right. Now you need to construct this. It's not called as a radial momentum operator in cylindrical coordinate. What does this coordinate called in cylindrical coordinate? Speak up. Okay, where is my question? Deleted. Okay, here. So this is for cylindrical coordinate actually. For cylindrical coordinate, something different will happen. Okay, pick up. Don't choose the same thing as that one actually. Okay, which of the following is Hermitian operator? You leave H bar. I should be there. Okay, rest of the thing you collect. Speak up. So I mean, this comes in that theory. Okay, now how do we solve this one without getting into that theory of constructing Hermitian operator? That we shall see. Okay, speak up. I hope in this integral only you can do something. But it's quite hard to predict that one. Okay, in this integral, how it can be done and all. Okay, or if you put this one in this integral. Okay, if you put this operator in that integral, if you do integration by parts. Okay, pick up. You should come to the first member. You should able to observe just like we proved px cap is Hermitian operator, I think that is bit lengthy than this theory. Doing integration by parts and proving that which one of the following. I mean, how will you do trial and error? That's not what you call feasible. Okay, I mean, what people will do after generating key answer, okay, after they generated key answer, they will try to do in that way actually. That's not feasible. Are you getting my point? You know the answer, then you can prove that it is Hermitian by doing integration by parts. That's not a feasible way. You better to work out this theory. Okay, it is there in MIT Open Coursera. I will share the PDF if possible. Okay, speak up. This is a way to construct a radial momentum operator in spherical polar coordinate. The same thing goes for cylindrical coordinate. The same thing goes for cylindrical coordinate. What you have to do? Speak up. In cylindrical coordinate, okay? So first you define del in cylindrical coordinate. Anyone? S cap divided by 1 dou by dou s, okay? Plus both gradient and divergence formulas are required, okay? Pick up to do this whole problem, okay? Plus I think pi cap divided by s dou by dou pi plus z cap divided by 1, okay? I mean, why to write this one? Again, you will understand later. Okay, speak up. Dou by dou z. This is your del operator. Okay, if you wish to find the gradient. Okay, speak up. Then we what this coordinate is called? Speak up. Axial coordinate? No. I mean in cylindrical coordinate. In spherical polar coordinate, that's called as radial coordinate. Am I right? Pick up. What do we call in cylindrical coordinate? This one? Axial distance. We say like this. Perpendicular distance from the z axis. Okay. Pick up. If you take a cylinder, I hope it's called as axial coordinate. I don't remember right now. Okay. Pick up. Whatever. Okay. I mean PS again the same thing. Okay. S cap dot P vector. Okay. Pick up. Plus P vector dot S cap whole divided by 2. This will be Hermitian. Okay. What did it called? Okay, he didn't name. Okay, we shall see that one. Okay, pick up this. Yes, only S cap dot P. Okay, this is not Hermitian. Unlike in Cartesian coordinate, you write I cap dot P. That's equal to Px. Am I right? This will be directly Hermitian in Cartesian, but it will not be Hermitian in spherical. Sorry, spherical or cylindrical. You need to do this one. Very similar step. Okay, you will end up with the answer, right answer. Okay, speak up. Now, anyway, you better to try this one after electrodynamics only while during the revision. Okay, you at least do this one. This also there. Okay, in some other exam, this is there. Okay, speak up. You at least do the spherical polar coordinate. Okay, so and you can try during the revision. Okay, speak up. I mean, lot of clubbed questions are there, especially in TAFR actually. Okay, pick up. TAFR, we created one separate web page actually. I mean, some miscellaneous question. Okay, 2 to 3 concept together, 2 to 3 topic together. Okay, they'll design the question. Okay, pick up. Now let me pick up other type of question, that radial probability related question. Okay, pick up. There are many questions. Okay, like that. I mean, especially in TAFR, I think I told, am I right, during the class, in TAFR, they are asking radial probability related question. Okay, speak up. An electron in 2s level, he has given what is the wave function. Okay, psi of r. Okay, pick up 1 by root of something normalization constant. Okay, so psi of r, I'll just write this is a. Okay, normalization constant. So 2 minus r by a naught. Okay, pick up e power minus r by 2a naught. Okay, speak up. The probability PR of finding the electron between the distance r to r plus dr. Okay, this we have done in Griffiths actually. Speak up. He called that one as, I think, radial probability density or something. Okay, probability of finding the electron between the distance r to r plus dr. That means irrespective of theta and phi. That word contain irrespective of theta and phi. Pick up. Now, what is the probability of finding the particle r to r plus dr? Okay, theta to theta plus d theta. Okay, phi to phi plus d phi. What is this one? Mod psi square into r square dr sine theta, d theta, d phi. Am I right? Speak up. So now look at here. So if you want to make it irrespective of theta and phi, okay, you will understand in the probability theory actually. Suppose if you toss two coin, okay, we write sample space, head, tail, okay, tail, head, tail, okay, pick up. So 4 element in the sample space, they are all equally likely. You are tossing two coin, okay, pick up. Each of them have got 1/4 probability. 1/4 probability. I hope you can guess this one. Am I right? Pick up. Now I need probability of first being head irrespective of second. How do you find this one? Probability of first one being head irrespective of second. Pick up. First one should be head, second one can be anything. You should add these two, am I right? Pick up. You have to write 1/4 plus 1/4. That means you need to add the probability corresponds to different second outcomes. Can I say like this? You will understand this one, okay, in the next week. Okay, next week means tomorrow. From tomorrow. Yeah. Like that here, if you integrate with respect to theta and phi, it will be irrespective of theta and phi. That's what I'm saying. We do this one in Maxwell velocity distribution, okay, in statistical physics, okay. Pick up. What you have to do is probability of finding that one r to r plus dr, okay. Pick up. That means irrespective of theta and phi, okay. That will be integration with respect to theta and phi of this one, mod psi square r square dr sine theta d theta d phi. Speak up. Now what I'm saying here is, I mean, this is purely radial, am I right? I think here L equal to 0, M equal to 0. When L equal to 0, M equal to 0, theta and phi will not come, isn't it? Usually your psi of r theta phi, that's equal to r of r I think n L, am I right? Speak up. Y L M theta phi, okay? Speak up. It looks like, I think 2s level, he has given 2s level here, okay. 2s means n equal to 2, L equal to 0, M equal to 0. If L equal to 0, M equal to 0, this part will not be there, am I right? Speak up. When you substitute this one, anyway, even though spherical harmonics is there, these ideas will not differ much, okay. Even though theta and phi parts are there, okay, radial probability idea will not differ much, okay. Pick up. That's why when you do this one, okay, speak up, this constant a mod square. So what will happen is you are not doing integration with respect to r square dr, okay, pick up, that you are keeping, okay. So pick up mod psi of r whole square into r square dr, this integral of sine theta d theta d phi, that will be 4 phi. That will be 4 phi. Ultimately, this is 4 phi into wave function mod square. I mean, I should not take mod a square. Mod a square is inside psi of r. Okay, speak up. Or if I wish to do this one generally, okay, speak up. Probability of finding the particle from, I mean, if I write psi of r theta phi as r of r, y of theta phi, okay. If I want to do this one generally, probability of finding radial distance r to r plus dr, okay, that means it is irrespective of theta and phi, okay. In Griffiths he has written this one as rho of r dr, very comfortable notation. Radial probability density, like that you can define like this, okay. So this is, speak up, theta and phi integral of, okay, mod psi r theta phi the whole square, okay, r square dr sine theta d theta d phi, okay. In this whole thing, okay, pick up rho of r dr, I mean that means this probability irrespective of theta and phi, okay, this r of r, okay, pick up r of r mod square, okay, into r square dr, okay, into rest of the part is spherical harmonics integral y theta phi, speak up, integral theta with respect to theta with respect to phi sine theta d theta d phi. I hope this will be 1, am I right? This will be 1.
For n is equal 0, m is equal 0, it is 1 by root of 4.
It is 1 by root of 4 5. That's why again along with 4 pi somehow it doesn't matter. This one constant actually. We are looking for that functionality. Sometimes most probable velocity. Most probable our radial distance. Okay, these things that we are looking for actually. That's why this is some
Mod square.
mod square. It should be mod square. Okay, I mean this is one constant. Am I right? After integral. Okay, if it is normalized, this equal to 1 actually. Pick up. That's why that constant I'll write, okay, into r square into mod of r the whole square dr. Okay, pick up rho of r dr. Speak up. Whatever may be the spherical harmonics part. Okay, that's why this is equal to this one. Am I right? I mean, he will write p of r. I'll write rho of r. Okay, that's equal to r square into some constant into, okay, r square into, pick up, r of r the whole square. Pick up. This is radial probability distribution. I don't know the word is right or not. Okay, speak up. Whatever p of r he is talking about, that is that one actually. Okay, that what is that one? Now simply pick up r square into constant into r square into mod psi r the whole square dr. Okay, because here there is no spherical harmonics in this question.
So
Okay,
probability is different from density. Here we are talking about probability.
probability of finding that one from r to r plus dr, that is right actually. This is dimensionless. If you take this one, it is per r. Am I right? That's what he has plotted. He's not plotting into dr. Into dr you can't plot actually. He's plotting this rho of r only actually. Sorry. He's plotting this rho of r only. R square into this one radial what you call wave function mod square. Okay. So now it is very simple now. Okay. Speak up. I hope you understood the whole concept. Okay, pick up. Now let me directly write radial probability distribution because there are many problems related to this one. Okay, pick up. So what is rho of r? I mean, for me, rho of r is comfortable per r. Am I right? Pick up. That's comfortable. That's equal to mod psi square. That's equal to some constant into r square into mod square of this one. 2 minus r by a the whole square into e power minus r by a naught. Okay, square of this one. Speak up. Now how do you plot this one? That's what he's asking. How do you plot this one? Now you just start analyzing this one. Look at here. Whenever exponential come at infinity, it always exponential dominate, whatever may be this one. Okay, exponential dominates. Whatever happens to exponential at infinity, you can do that one. I mean, at infinity, r is between 0 to infinity. Okay, speak up. So when r tends to infinity, exponential dominate, it should go down. Okay, all of them are going down. Okay, it's not working. Okay, at r equal to 0, this whole thing is 0. Speak up. That's why you can avoid one of the option. You can avoid this option. Now the very best thing is, okay, I mean, look at here. This will make the whole curve 0 at infinity. What will make the curve 0? That is this part. What will make the curve 0 in the finite r value? That is this part. Are you understanding this one? Speak up. So that's why when you take the root of this equation, isn't it? Speak up. How many roots you will have? You just equate this one to 0. R square 2 minus r by a the whole square equal to 0. Am I right? R square equal to 0. 2 minus r by a the whole square equal to 0. R equal to 0. R is equal to 2a. At 0 it should be 0. At one more point it should be 0. But this both option have got at 0, at one more 0, at infinity. At infinity it is 0 because of this one. Okay, you need some practice, graph plotting skill only. Okay, speak up. At infinity it is 0, you don't count that. Okay, at finite value it should be 0. I mean, again you can avoid this one now. Okay, either of these two. Are you done? Fine. Because of this factor, it is 0 at 0 and it is 0 at r equal to 2a. Still not over.
Now we need to derivative with respect to R, which is higher. Because they are comparing the
Got it,
values,
got it.
maximus. First maximum is
I mean,
zero, second
if you take derivative, if you equate to 0, you will get 1, 2, 3. 3 extremum. Okay, among them 2 maximum. Which one is higher? You need to check. How long it will take? I mean, you have to think about time also. Am I right? Exam question. Pick up. That's why what I'm saying is you need to have a note on that one. I hope this is this one only. I mean, I'm feeling like that. This one or this one?
Now we can try to solve of the exam. We can skip.
No. In exam you can skip. Yeah, that's true. You have to skip if this is this much lengthy. Okay. Now what I'm saying is go back and list out. I told, am I right? Spherical harmonics in the table you need something. You have experience in many exam it is required. Okay, exam question. Okay, and this radial wave function, it is required actually. Pick up. If you see the list of radial wave function, you can do this one actually. If you see the table or whatever the plot that he made actually. He plotted directly radial wave function, not mod square into r square also comes actually. Can you check where it is plotted? Somewhere in the Wikipedia or somewhere I have seen. Okay, they have plotted this one. Okay, radial probability distribution. Any way to eliminate among these two? Anyone?
So can you compare between exponential and polynomial?
If you plot polynomial, if you plot exponential, then together you can judge something. Speak up. If you plot this one, if you plot this one, okay, you can judge something then also. Okay. Yeah. Think over it. Okay. Think over it. How to proceed here, or you can use GeoGebra to plot this one and try to compare. Okay. Use GeoGebra to plot this one and try to compare. Okay, but that is not allowed in exam. Okay, pick up GeoGebra. Pick up. But this is the basic idea. Okay, and you should remember this one. Okay, pick up. GeoGebra. Okay. Yeah, once you know the function, you use GeoGebra to plot it. Okay. What you saying?
So can we take the root of the rho r and rho, because
That's what I have taken.
squares.
Root.
No, sir. The r square into 2 minus 2r, 2 minus r by d whole square.
Root means what you mean by a square root. Why? Why would you take square root? No. I mean, on what basis you take square root? You tell me. That's it. You can do that one, but you have to tell me. I mean, this one equal to 0 or this one equal to 0. That's how you have to see this equation. At least I can eliminate other two options. Okay. I mean, check out. I mean, using GeoGebra, how to deal with this one. Okay. Speak up. You can guess how many extremum and all if you take the derivative. Again, finding maximum, minimum, it can be doable, but time consuming, but not feasible for the exam. Okay. Finding the what you call value of the function at this maximum and checking which value will give you higher value. Okay. That is too lengthy process actually. Time consuming process. Okay. That's what I'm saying. Okay. Okay. I will move on here. Okay. So now this one again, I hope again graph plotting is maybe again lengthy. Okay, the same state. No, 2 minus r by n naught. Am I right? Speak up. 2s level, okay, the same state actually, okay. The probability of finding the electron, okay, somewhere inside the sphere of radius lambda or not. Speak up. What you have to do, you take this one, okay, you take this one, you have to integrate this one between 0 to that radius actually. This is a probability of finding from r to r plus dr. You have to integrate this one from 0 to that radial distance, then you will get a probability of, I mean, you are already integrated with respect to theta and phi, only one r integral left here, isn't it, logically? So
In mathematical physics, it's not really focused.
no, because this part is Legore, this part is something
Yeah, those things will be there.
separately. Here we need together actually, okay. Pick up. So now what I'm saying here is, I mean, probability of finding that one, okay, from r equal to 0 to, okay, r is equal to, not r to r plus dr, okay, probability of finding from r to r plus dr, okay, I call that one as rho of r dr, that's equal to some constant into r square into mod r of r the square. Am I right? Speak up. Now, if you want to find probability from 0 to lambda a naught, what you do? You just integrate this one. Or you can start with the what you call total wave function. You can integrate with respect to r theta phi, where r should run from 0 to lambda a naught. That also you can do. But I have already radial probability distribution formula here. dr, sorry. dr, isn't it? Theta and phi already integrated. Then you got C here, okay? Because only one more integration is left here. That is radial integration, okay? You just think over it, okay? 0 to lambda a naught, okay? Speak up. R square into some constant square, okay? Pick up 2 minus r by a naught, the square e power minus r by 2a naught. Oh, integration by parts.
The parts.
What else you can do? After integration by parts, this will be some function of lambda, am I right? You have to plot with respect to that lambda.
Is it C?
Huh?
Is it C?
No, it is D. Don't gamble here. Don't gamble here. You leave it. Okay? Speak up. I mean, that attitude is not good for exam. Okay? Speak up. I mean, whatever attitude we develop towards the exam, that's not good. Okay? Guessing and then negative marking. Why do you? I mean, when you, if you can do many problems, why do you lose some marks? Isn't it? You spend time on other problem. If you guys can generate any idea, any other way, think over it. Okay? All this whole radial probability related problem. Okay? I think I told during the class this is one headache, especially TFR problem. Okay? Speak up. I hope this can be done. It's not so difficult wave function. Okay? Pick up. This can be done. Speak up. What is this one? So wave function is, I think this is your ground state wave function. Okay? Speak up. Psi 100. 1 by root pi a naught cube actually. Okay? E power minus r by a naught. Okay? Speak up. So now, which of the following figure qualitatively depicts, okay, the probability of the electron within the distance r from the nucleus? That means it is very similar to last question. We said probability of finding that one from inside the sphere of lambda a naught. Now here he is saying inside the sphere of radius r within the sphere. This is not radial probability density. That is r to r plus dr. R to r plus dr is different from finding the particle within the sphere. That's why what you need to do is, okay, I mean, again, mod psi of r square into mod r of r the whole square, some constant you keep, okay. So dr, okay, you have to integrate from 0 to r. No, don't guess. Do that one. Why can't you do this one? Now, while doing this integral, okay, you got my point? Probability of finding the particle, this is actually, this whole thing is actually speak up. Probability of finding that one from 0 to R, am I right? Speak up. Can you say like this? Probability of finding that one from, or I will write like this again. Probability of finding that one from R to R plus dr, that's equal to rho of R dr, okay, that's equal to some constant into R of R square into R square, don't forget R square factor, okay, R square into R of R dr, okay, speak up. So then probability of finding that one from 0 to R, okay, that's equal to integral 0 to R, so C R square, okay, I will absorb this constant here, e power minus R by A naught, am I right, or e power minus 2R by A naught, okay, into dr. Now, what you have to do is, okay, in the integral, if this is the integral limit, this should not be the same variable actually. You put R prime inside, mathematically. Integral limit and this inside variable should not be the same actually. Or you take this one as R naught. Okay, I'll take R naught here. And this will be some function of R naught. I hope this can be done. Integration by parts. It's not as big integration by parts as before actually. Okay, I think A or B may be the option. Okay, check this out. I mean, this you do this one. This integration by parts is not lengthy. Okay, whether it goes to 0, whether it goes to constant. Okay, pick up. You can check this out. Look at here, graph plotting skill again. Let us see. I mean, over time, I mean, you will understand some logic to plot the graph and all. Okay, just the same. I mean, if you take a, this is exponential kind of curve actually. Okay, you can check this out. Okay, whether this is or not. So this one actually, I hope this is R into e power x into e power minus x. Okay, this looks like this kind of curve. When x equal to 0, it is 0. Okay, speak up. I mean, you should have some experience also while judging, isn't it? Because you can't do all of those derivative again, checking the maxima, isn't it? You can't do all of them actually. Okay, speak up. 0 to R naught. 0 to R naught here. Okay, do it again. Okay, I think we have to close it. We shall start with basic permutation and combination tomorrow. Okay, and let us start sharply at 6 or 605, and from 7:15 to 7:30 we shall pick one problem. Somehow you guys just insist me to solve one problem, daily mark one problem, then this extra class is not required, am I right, at the end of the week. Speak up. Tomorrow 1 hour I will quickly deliver permutation, combination, some related examples. Okay, and you need to do some NCERT textbook problem, then we shall quickly jump to this one. I'll close that YouTube video. I will make another YouTube live so that I can store that one separately. That's how we can handle. Okay, any question on Google Meet? Yeah, this first question went lengthy, am I right? Anyway, new question. Okay, yeah. Okay, we'll meet tomorrow.
There must be some logic to solve it easier, no, sir. Otherwise, they won't give it.
Which one?